So today in the lesson, we will learn how to evaluate machine learning or data mining models. So what is our aim to evaluate the machine learning or data mining models? When you have trained a model, when you introduce your data set to the machine learning or data mining algorithm, it is producing a data mining model. For example, this decision tree model. You are generating this decision tree model, or like that one artificial neural network model, for example. And you can use this model to make prediction. And then why we need to evaluate our model? We are going to use evaluation to measure the quality of our trained model or machine learning model. So you can use different criteria to evaluate. For example, one of the most common used criteria is a predictive or classification accuracy. You can use predictive or classification accuracy. For example, you generate two models. One of them, for example, neural network model, model A, you have model A, and model B. And model B, for example, decision tree model. And then you want to know which model is more accurate. Yes, you can measure their accuracy. How, if you are asking how to measure their accuracy, there is several methods. We will learn them in the coming slides. And you can evaluate them, which model is a more accurate than other, which model is a making better prediction. You can evaluate like that, or by means of the speed. When you are mentioning about the speed of the model, actually you want to mention training speed. For example, you have two different machine learning or data mining model. One of them model A, other one is a model B, and then you want to know which one is a faster than other by the means of the training time. For example, if usually decision tree models get less time to train, yes, but neural network models usually get much time, require much time to train them. By means of the speed, you can evaluate which model is better, or by means of the robustness, you can evaluate your models. When you tell robustness means if in your data set, if there is some noisy data or some missing data, how responding your machine learning or data mining model to that noisy data or missing data, if it is affecting too much, or if it is affecting less, or if it is affecting if it is not affecting from the missing data or noisy data, you can evaluate which model must be more robust model. For usually decision tree models, usually it is like that, not always. Usually decision, for example, support vector machine model is a more robust model than others. Another one is a scalability. When you compare the two decision tree model or machine learning models, we can compare them by means of their scalability. For example, you have data, and then you have used this data set to train your decision tree model or machine learning model, but your data every day increasing amount of data, and then you can retrain your model by using new coming data to make your model familiar with the new condition, or to improve the accuracy of your model. But if your model is not scalable, and your model cannot deal with certain size after certain size of the data size, that's why scalability is one of the important another issue. Usually decision tree models, they are more scalable, and this means they can deal with large amount of data than the other models. Interpretability. So when you train a model, when you generate a model, when you have a model in your hands, and you will use that model to make prediction or to analyze your data. But if you, for example, if you have decision tree machine learning or data mining models, you can see what is happening inside. You can get inside that model, and you can make some conclusion by using that model. For example, attribute of this value, if it is bigger than, for example, this certain amount of the value, we'll choose this option. And for example, if value of the second attribute smaller than this one, choose this option. Bigger than this one, choose this option. You can see what's happening, and then you can see the inner mechanism, inner system of the model. But there is some models like artificial intelligence model, like for example, they are inner states, mostly gray. You cannot see what's happening inside, and you cannot conclude from input to an output. If you change one input, how it will affect the output. It is a gray model. We are calling them gray box model. Gray box model. You are not able to see what is happening inside. But decision tree model is a glass-like model. Glass-like model. And you can, if you have model, you can, if you have new data, you can easily follow what's happening and how it will conclude the result, how it will produce the result. If something happened like that, something happened like that, and this output will be yield. You cannot. And also there's some models like that support vector machine models. They are the black box model. At all, you cannot. You don't have idea. You have only input. When you give the input, and you will get one output. You can get the output. You can see the output, but how this machine learning or decision tree machine learning or data mining model get or find out that result, you cannot know. You don't have an idea about it. But model, if there is some input, it will produce or it will yield some output. It is a black box model. That's why if you want to analyze your data, it is better to use more interpretability models like decision tree models, for example, or simplicity. Your model will be complex or simple. Always simple model is better than complex model, because complex model can memorize your data in your hand, but they will fail when they have seen the brand new data set. That's why simple models can produce or they can generalize, they can find the general rules about your data set to describe. Also, there is some domain-dependent quality indicators. It is depend. For example, if you are developing machine learning model or data mining model, you need to involve into one domain. For example, in the health sector or education sector, tourism sector, finance sector. For example, if you are predicting the dollar price, this means you are working on the finance sector. Every domain, they can have their own quality indicators. You should follow that indicators to evaluate your models. So how to evaluate? So if you want to know, for example, you have developed several different machine learning or data mining models, and you want to know which model is better than other. How can you evaluate? To evaluate your models, we are going to use validation techniques. One of them is to divide your data into the training and test or validation set. You have one data set, and you are dividing it into the two parts: training data set, test or validation set. If you are dividing your data set into the two parts, first data set, it is called training data set. Second data set can be called as a test or validation, because you have to aim to divide your data. First aim, it can be, you may want to estimate accuracy of your trained model. You want to know, for example, you have one model, you generate or produce one model, but we want to know what is the accuracy of that model. For example, Irish flower expert system. You want to know if you are making one prediction, which type of the flower this one. For example, you want to know if this prediction is a 90% correct or 95% correct. You want to know accuracy, or you want to measure or estimate the accuracy of your model. That's why you can call it test dataset. Or sometimes you may want to know when you trained a model, and then when you get at the end one model, you want to know that model is a correctly configured. Yes, how you are configuring a model. When you are configuring models, every decision, every data mining model and machine learning models, they have some parameters. You need to configure them. And according to the configuration of the model, you can get better models. What is that parameter? That parameter can be hyperparameters or system parameters. We will learn what is the hyperparameter and then system parameters. All these parameters is weighted to be set to the correct values. If you can set them into the correct values, this means you have one well-trained model, effective model. Yes, some of them, these parameters should be configured by the user manually by yourself. Some of them, they will be configured automatically by the training algorithm, and they will be learned by the trained algorithm automatically from the data set. Yes, and then this means what is your ultimate aim? To divide your data into the training data set and test or validation test set. If you are dividing your data set to test or to estimate the accuracy of this one, you can call the second part of data testing data set. But if your aim is to validate if my trained models, configuration of trained model is a correctly set or correctly configured by means of its hyperparameters or system parameters, if you want to find out that one, in that case, you can use the second part of it for the validation. That's why you can call it validation. According to your aim, you can call it testing or validation. Sometimes in this approach, you are dividing your data into the 3 parts. First part, it is called training. Second part, validation. Third part is a testing. When we are using this technique, for example, sometimes you don't have access to test data. They will not give you test data. Usually in the competition, for example, you have one data science competition, and then they are providing you data set. They provided you data set, and then by using this data set, you develop one data mining or machine learning model, and then when you upload or submit your model, they will test accuracy of your model by using their test data. That's why they will not provide you to the test data, and then it will be hidden to you. In that case, what you need to do, you should divide your data into the 2 parts: training data set and validation data set. You can use some part of your data set to train your model, second part of your data to validate the configuration of your model or to test the accuracy of your model. Also, in some machine learning models, for example, artificial neural network, their training algorithms, they will run for several rounds. For example, in the first round, it will get all data set, and then it will make some training, and then it will make some optimization, and it will find the some values for the system parameters, and it will configure your machine learning or data mining algorithm. And then in the second round, it will again get the input data, train your data set, and it will again reconfigure, and it will obtain at the end more better result. And it will continue training like that in third round, fourth round, sixth round. It can continue like that 1,000 rounds, 1,000 times, 100 times. The artificial neural networks can introduce training data can be introduced to the artificial neural network. In every round, it can improve across of the model. But in that case, there's one problem. At the end, your neural network model can be overtrained. Overtrained means because it is making training several rounds. Not in the decision tree, for example, you are going to give your trained data one time to model, and then one time it is making configuration. But in the training, artificial neural network training algorithm has using different system. It can get several. It can make several rounds to train. In every train, a little bit, it can improve. In that case, but there is one problem. It can be overtrained. If it is overtrained, this means your neural network memorize the trained data set. When it is faced with the brand new data set, it can be failed. And this means you should find out one right stopping training round. Yes, for example, if you want to, you can train artificial neural network models 100 times, 1,000 times, but in one point you should stop and you should not train anymore, and you should find the optimized trained round. Yes, how can you do this one? You can divide your training data set into the two parts explicitly by yourself, and you can use some part of your data set as a training, some part of it to validation. Let's see this graph, for example. For example, where it is trained, look at, it is trained 18 rounds, 18 times. This means training data set introduced to artificial intelligence algorithm 18 times. In every times, look at, error is going down in the training data, validation data, test data. Yes, several times. But if, for example, in this point, this point is better than this one because it is less accuracy by means of the validation. By means of the training, also like that. This point, for example, error is here less than this one, and continue like that. For example, here in this point, error is smaller than this one. But look at, pay attention here for the training data. In this point better than this one by means of the error. This point it has less error than this point. It is better. Look at when you are training, when you continue training in this round, in the 13th round, in the 13th round, you get better model by the training. But when you validate by using validation data set, it is your error is going up. This means in this point, training error continued to going down, but validation error, it is not going to down like that. And here, increase here. This means it is a right place to stop training. Yes, after that, after this point, your artificial neural network model started to memorize your data set. That's why it is a best stop here. And in that point, it is your right configured model, and you can stop here. And you can use this validation data set by yourself. You can define it here. For example, in the WEKA, you can tell 10% of the my training data will be used for full validation. This means if you set, for example, 80% for training data, 90% of it will be used for training, 10% of the training data will be used validation. For example, this one is a threshold. If like that 6-step stop, for example, it will test in the first try, validation accuracy increases. In the second try, increase. In third try, increase. Fourth, increase. After 6, don't try anymore. This means, and stop here. Yes, because in sometimes, for example, in this point, validation can go up, and after that stop, it can continue. Maybe it can continue again going down. That's why you can continue training. But if you fail 6 times, stop training in that point. In that point. So in some models, you may divide your data into the 3 parts: training data, validation data, and test data. This validation, in that case, will be used not to find the accuracy of your model. This data exactly will be used for what? To find the in which epoch, in which training round I should stop the training. You will use it, that one, to validate, to configured parameter of your neural network models. It is right configured or not. Yes. And then test data, in this case, will be used to test your accuracy or estimate the accuracy of your model. So when you're developing, when you're developing one data mining model or machine learning model, you need to specify some parameters related to your model, hyperparameters and parameter or system parameter. We can tell it model parameter, we can tell it system parameter or learnable parameter. Hyperparameters, they are the user-defined parameter. You should configure them by yourself. And I will come to this point later. System parameter or learnable parameter will be learned or set by the training or learning algorithm, not by you yourself. So when you are, we told, when you want to evaluate by means of the accuracy of your model, you can divide your data into training, test, or validation data set. And then you will use the training data set to generate your model. And then to evaluate accuracy of your model, you will use test data set. When you are training your model, you will not introduce test data set to do learning algorithm. And then later you will use it, you will put it to side, and then you will use it after training is completed, and you will use this test data to measure the accuracy of your model. Because if you not use test data set to report accuracy of your data, you need to use training data to report the accuracy, but it is not good indicator to performance of future data, because during the training, your machine learning algorithm or data mining algorithm used to see and use training data. If you measure the accuracy of your model by using training model, you may fail or you may report the wrong accuracy. Also, training, when you can train your data, but when you train your data, when you introduce new data to the trained model, new coming data may not look like the trained data. That's why you should separate exactly 2 parts: training part and some part to test part. And by using training part, you should train your data and you should train your model. After, when you finish the training of your model, you should provide the test data to the trained model to see the accuracy. So how can you measure it? For example, you divided your data into the two parts, and by using this part, you trained your model, and then by using test data, and then you have a model, for example, decision tree model, yes, and you can give this one to your model as an input. In the test data also, you know the result. If it is input this one, for example, output is a false. If it is input like that, output, for example, true. And you can provide this input, and you can ask to make prediction from your model, and you can compare. For example, if correctly, for example, think in your test data there is 100 rows, and then when you introduce these 100 samples to the decision tree models, it 80 times correctly. 80 times correctly answered, and then all together size of this one is the size of the test data T, size of test data 100 here, and this means 80%. Accuracy of your model is 80%. If you want to find the misclassification error, totally you have 100 data set, 100 in the 100 sample or row in your test data, and correctly answered all of them 80. They all together 100. This means 20%. Yes, 20% accuracy. You have 20% misclassification accuracy, and then you have 80% correctly classification accuracy. Another example here. For example, you trained one decision tree model, and then correctly classified instances is this amount. And then in your data set, if there's a 3,333 data set, what is the accuracy of it according to the formula? If you divide it correctly classified by the all data set in your data set, you can find 94% accuracy. And misclassification error is this one. All data set, this one. In your data set, you have this amount of the sample, and minus correctly classified divided all. 5.97% is a misclassification error. This one is a correct classification error. This one misclassification error. This is according to the training data set. In the test data set, you have 100. You have 100. We missed here. There's 100 tests, and 90 of them correctly classified. This means 90 divided by 100, 96 divided by 100. Accuracy of your test result is a 96. Misclassification error, this one. It was one example. So how can you divide your data into the training and testing? You have three approaches. You can use hold out techniques. You can use k-fold cross-validation technique and leave one out classification technique. There's more, but there are these three of them, the more common techniques to divide your data into the training and testing. In the hold out technique, how can you divide? In the hold out technique, usually you have one data like that, and then you are dividing into the two parts. Training, some part of data will go to training, other part of data will go to the testing. You are dividing into the two parts like that. So when can you use this method? If you have large data set, you can use these techniques. And when you are dividing your data into the two parts, how much percent of this data will be training, how much percent of the data will be testing data? Yes, normally 2/3 of your training data data will be used as a training data. 1/3 of your data will be used as test data. Say normally, if you have large amount of data. But if you have small amount of data, you can use 70% for training, 30% for testing. Or if you have smaller data set, you can use 80% for training, 20% for testing. There's no rule for it. If it is large, if you have large data set, quite large, you can use 2/3 of it for training, 1/3 of for testing. If you have medium data set, medium sized data set, 70% for training, 30% for testing. If you have close smaller data set, 80% for training, 20% for testing you can use. In this one, again, same. We are using training data set to build our machine learning or data mining model. And then after that, when you are training your model, we are not introducing this data because we put it to the side at the beginning. We divided our data at the beginning, and then we only introduced the training, this part of the data to the training algorithm. We didn't introduce this side. After that, we can use this part to test accuracy of our model. Yes. So selecting size of the training and testing data set is trade-off. It will be 7% to 30%, 80% to the 20%, 2/3 to the 1/3. It's a trade-off. There is no one rule to say that. There is a trade-off between performance and evaluation accuracy. This means if you have more test data, you can estimate more accuracy of your model because you have much test. You are making much test. How accurate to know? You can know better. You can estimate accuracy of your model better. But if you are using if you increase the test data set, this means you are reducing from the training data set. And if you are using less training data set, this means you may not have enough data to complete the training of your model. Yes, that's why you can reduce. It may cause the worse model. Yes, if you are using less model. If you have more training data, this means it is obvious that you will have better model. But if you are using, for example, 90% of your data for training, 10% for testing, in that case, when you report, for example, you have this model, you get one model, decision tree model, you get one, and you report it, it is a 96% accurate. But it is suspected because you have just 10% data to test it. Yes, you should test it very well. At least 20% you should use. Yes, you cannot estimate the accuracy of this model with less test data. You should increase the amount of the testing data with a confidence. If you want to report its accuracy with a confidence, you should use much test data. Yes. And if you use, for example, 60% for training, 40% for testing, and you can make sure your accuracy of your model better. You can guess or estimate accuracy of your model better, but you cannot obtain one good or well trained model because you have used less training data. There is a trade-off. Yes, the most common approaches these ones to divide your data into the training and testing. So at the beginning, you are dividing your data into the training and testing. After that, you are using this data, you are introducing this data to the algorithm, data mining or machine learning algorithm, and then you are generating a classify. In this case, we are generating one decision tree model. Yes. Now we have one decision tree model at the end. Yes. In the next step, what are you going to do? You are introducing test data to your model, and you're asking if inputs like that, what is your output? And you're comparing the real output, and then you're finding how many times give correct answer. And then what is the size of the testing data set? When you divide it, you can calculate easily percentage of the accuracy. So in the last step, what can you do? You can do one more optimization. When you find out your accuracy, you can give all data. You can give all data to algorithm, and you can train again your model, and you can get another better model, because in this time you have used much data, but you cannot tell anything accuracy of this model, but you are sure this model is better than this model, because this model trained by using only this amount of data. But you can tell the accuracy of this model because you test it. But here, now, you don't have chance to test it. But you know one thing, this model is better than previous model, because to train this model, you have used much data. Yes, you can, before deploying to use in the production your data, you can use all your data to train your model to get better result. Yes, we talked this one. Holdout model has some cost. Yes, what is the cost of it? You should divide it in your data into the two parts. Yes, if you have quite big amount of the data, it is not problem to divide your data into the two parts. But if you have small amount of data, for example, think you have 80 rows of data, and when you divided it, and then when you divided the data, at the end you will have not too much data. Yes, and it may not help to train your data. It will cost to removing some part of data for testing. Yes, it has cost. So in that case, what can you do? So in that case, you can do repeating process with different holdout sample. Repeating. What can you do? For example, instead you can divide it your 90% and 10%. You can use training and testing. Again, you can divide it randomly, 90% and 10% again. And you can train and you can test. Again, you can make this holdout method 3 times, for example, repeat. With different randomization seeds, you can divide it randomly, 90%, 10%. And when you want to report to accuracy, you can add the accuracy of this one, and you can divide them to do 3, and you can report like that. It is better, but in this case, what's the problem? And some training and testing data can be overlap. So if you are using also repeating holdout, it is good idea to report standard deviation. Later, I will come this point back and I will show them in the practical. And then you will have some difficulties from statistical point if you are using repeating holdout sets. If you are using repeating holdout sets, you have some difficulties. What is the, for example, if you want to compare 2 models, for example, you have model A and model B, and then you want to compare their accuracy. Which one is a statistically better than other one? You can use t-test to compare accuracy of these two models, you can use t-test. But if you are going to use repeated holdout method, you cannot use t-test. You need to use another test, paired t-test. You can use paired test. In that case, you should use the paired t-test. If this means if you are using repeating holdout method, you should use the correct statistical testing model to compare your models. So in another method, we told holdout method. Second model is a cross-validation error estimation. Cross-validation error estimation. In the cross-validation, what are going to do? You are dividing your data into the several parts, like that. For example, in this one, you are dividing your data into the 5 parts. 2, 3, 4, and 5. And then 4 part of data at the beginning, in the first round, 4th part of data you are going to use to train your data. And 1 part of data you are going to use for testing. In the next time, you are using this part of your data for testing and this remaining 4 part for training. And this part, next time, this 4 part, we are going to use for training and this part for testing. And we are repeating it 5 times. And then when you are reporting accuracy, you are adding accuracy of the result coming from this test data set, accuracy result coming from this test data set, add sum of all of them and divided by 5. At the end, k is here 5, and when you get average, first of all you are summing all of them, sum. After that, get average, and you are reporting it like that. And also you can make it tenfold. As in the tenfold, you are dividing your data into the 10 part, and 9 part of it for training in the first round, 1 part of it for testing. In the next time, second part will be used as a testing data set, remaining 9 part, 8 from here, 1 from here, 9 part will be used training. Like that, this means if you divided your data into the 10 part, you are using tenfold, 10 times you are doing this one. And then your accuracy of this result plus accuracy of this one plus accuracy of this one plus divided by 10 will be your report, accuracy report. What is the advantage of this one? It will avoid overlapping. Yes, because you are dividing your data at the beginning 5 or 10 or any fold. Yes, any fold. You can divide it. And it is not overlapping. For example, in here, if you use for testing, you are not using this part for training. If you are using this part for training, you are not using for it testing. But in the repeating holdout method, some data can be overlapped because randomly you are dividing your data. Randomly, 90%. First time, in the first round, randomly you are getting 90 of them for training, 10 of them for testing. In the second round, again, 90 of them randomly. Yes, in the first, again, randomly selecting. This means some data can be overlapped. Yes, but here, there's no like chance. In the first step, we thought we are dividing into the k part. Each subset in turns used for testing and training. Yes. Also, there is a common practice to stratify the subset. Also, this is also valid for holdout method because, for example, you have data set, 100 data set, and then for the 100 data set, and then on 90 of them, for example, setosa flower, and 10 of them only versicolor flower, coming from versicolor flower. So when you divide, for example, 80% randomly 80% and 20%. If all these versicolors will go to the randomly because you are dividing, go to this set, what will happen? In the test data set, you don't have any sample or representative for this class. Yes, it is a disadvantage. Yes, that's why you can use Stratify. When you can tell, for example, when you are dividing all these 100 sample in your data set, 9 of belong to setosa flower type, 10 of them versicolor flower, and then when you are selecting randomly 8 of them, you can select 80% of this one and 80% of this one. And now in the training data set, there is a representative from the two set. Also in the training data set, there is a representative of the stratifying, also good strategy you should consider. So when you are estimating, when you want to report the estimated error, you should average. Yes. Why? You should average because you do this process in this example of training and test 5 times. This means you get 5 score, accuracy score. You get 5 accuracy score, and then you should add sum of all of them, and you should get average of them to report it. So when you have small data set, it is a good approach, good techniques to use. If you have small data set, it is better because, for example, if you are using 10-fold cross-validation, for example, 90% of it you are going to use for training. Yes, you have already small data set, but 90% of as much as getting much of them for training, 10% of it for testing. Yes, and then you are repeating this one 10 times. Yes, that's why it is not a problem here to use less amount of the data for testing, because you are doing this test 10 times and you are getting average. You'll get more reliable because of the repetition, more reliable test results. So if you have small data set, it is cross-validation is the best option to use to validate your data. So you can use 10-fold. If you have bigger data set, you can use 5-fold. If you have bigger data set, you can use 3-fold. You can use 3-fold. If you use 2-fold, it will be holdout, similar to repeating holdout. Yes. It is up to your data set size. If you have very small data set, for example, if you have in your data set, if you have 50, 60 data set sample, it is better to use, in that case, directly 10-fold cross-validation. Yes. But if you have, for example, 300, 400 data set, you can use maybe 5-fold. 600, 700 data set, you can use 3-fold. If you want to make sure, sometimes in the holdout, you are dividing your data set into the 2 parts. Yes. And then that's why sometimes, even if you have big or medium size of the data set, if you want to get more reliable result, you can use 2-fold or 3-fold cross-validation. It is better than holdout. Holdout cross-validation, K-fold always will give you more reliable estimate error. Yes. And another method, leave one out cross error estimation. In that case, if for example, if you have 100 samples in your data set, and then if you are using 100-fold, this means you are using these techniques. Yes, 100-fold. What does it mean? If you have 100 sample in your data set, and then you are using 100-fold, this means you are dividing your data to the 100-fold, and then one of them for testing, remaining 99 of them for training. And how many times you will repeat this test? 100 times, n times, because your size is 100 n times. It will take too much time, but you will get more reliable result by means of the accuracy report. Yes, if you have very small data set, this method is a best option. Very small data set. For example, if you have 50, 40 in your data set, and then you should use this one. Maybe you will repeat your experiment or simulation 50 times, 40 times, but at the end, you will be more confident to report to or to see the accuracy of your model. We thought for large data set, you can use 3-fold. For small data set, 10-fold. Even for very, very smaller data set, you can use leave one out cross-validation techniques. So we thought you can divide your data into the two. If you're dividing your data into the two, this means first part is a training data set, second one is a testing or validation data set, or validation, you can call it. Or you can divide your data set at the three parts. We told if, for example, if you don't have access to test data set, in that case, explicitly you should divide your data into the two parts. One part will be used for training, other part will be used to estimate accuracy or to validate the configuration of your model. Also, we told some models like neural network models, we are calling it early stopping techniques. Yes, they are introducing training data several times, several rounds, several epoch. Yes, several epoch. In each time, accuracy of your training accuracy will improve. Look at error is going down, going down. If you follow this purple or blue color, look at accuracy. In every training is accuracy going down. Maybe if you continue, it will continue to going down. Better accuracy. But actually, after this point, we explained it is memorizing. That's why you should not. Accuracy is going better because error is going down. But when you introduce this model to the brand new data, it will not make correct prediction. That's why this point is the best stopping point. That's why you can, in some model like artificial neural network, you should divide your data, train data into the further, some part of it to the validation set. We'll give all these examples. Now, how can you make this? How can you apply these models in when you are developing your models? Let's start from RapidMiner. New process. And then for example, we want to develop one decision tree model. And then let's read our data first. Read from the exam. And then we can use wizard to read our data. And then where is our data? Inside the Irish, all data set here. In the previous lesson, if you remember, we have used all data for training. Yes, it was wrong. Yes, you should divide your data to training and testing to see the accuracy of your model. Yes, Now we will divide our data into the some part. For example, to make it, you should use evaluation. Yes, evaluation and validation. And let's use first split validation. Split validation is a hold out techniques. This means it is dividing your data into the two parts. Yes, let's bring data here. And how many percent? Look at, let's go to slide to see. So you are in this techniques, in the hold out techniques, it was hold out error estimation technique. Yes, if you recall, we have three techniques: hold out, k-fold, and leave one out technique. Yes, these two of them using much. Yes. And then we want to, our aim is to divide our data into two parts. And then we told if you have small amount of data, much amount of data, we don't have much amount of data. Why? Because let's look at, we have around 100. We have 147 data around coming from the Excel. Yes, 147. If you want to see it, you can see it. Yes, which data coming, you can see it. Let's make it to disabled for now. And then let's run this data. This data coming from Excel, 147 data we have. And then we want to divide our data into the two parts. Here I am writing, I want to split my data into the 80% for training, remaining one is a testing. How can you divide? You have two options here. Absolute or relative. Now I have used relative techniques. 80% I divided for training, 20% for testing, and then, but also you can use absolute. You can tell number. For example, we know there's a 180. I can tell instead of relative, absolute. I can tell. For example, I can tell 100 of them for training, 100 sample, randomly selected 100 sample will be used for training. Remaining, -1 means remaining. If you know exactly, you can tell, for example, 47. We know in this example 47. You can tell 47. But if you don't know remaining how much, you can tell X -1. -1 is the remaining part. But we want to use relative. This means 80% for training, 20% for testing. I want to use because my data set size is not big. There is a 147 sample inside it. That's why I don't want to use 7 to 30%. I want to use 80, 20%. And then from here, I want to see model, output, training result, and then average. And then it is a nested module. That's why you should go inside and you should do. And here, now we are inside the validation. Yes, we will use these validation modules. When you double click it, you can enter inside, and there is a training and testing. In the training, what we want to train? Decision tree. Decision tree algorithm. I'm getting. The training sample will come here, and model will go from here there. I am using 80% of data will enter from here to training. We will train model, and then now I want to. I will train my model by using 80% of my data, and then when I training finish, trained model will be output from here, and in this section I will test my trained model. This one. How can I test this one? I should choose apply model module. Apply model. Apply model, and then I should also choose performance module. Performance. If you make bigger, you can see performance for classification module. Because this is a classification problem, I will use it. And I will send the output here. And then test data. This module training decision tree algorithm will get training data. But this module will get model from here. This section will train my model, and it will give my model to this place, and then testing data. I am going to give test data. Now I am applying test data to the trained model, and I am getting a labeled predicted output here, and then performance output. Average will be output. When you go up, you can see this one. This one will be output to my average. When you run, and you can see 96%, 96.55 my accuracy of my model by means of the testing data. Yes, because 20% of data, at the beginning, I divided 80% data for training. 20% of data, I put it aside, and then I have used that data here to test my model coming from the here. Yes. So this is a holdout module. To make the holdout, you can use this one, and you will get the result. Also, if you want to see, for example, you want to know, for example, this accuracy, reported accuracy is a test data. But I want to see training performance. How can you see training performance? I am doing training here. Yes, I can do the same things here. Copy and paste. Model come here, and then look at here. Training data came to my learning algorithm, and then learning algorithm train, and it produced one model. And I want to see its accuracy. I'm going to give this apply, and then training sample here. Look at when you go here. Look at 118. Be careful. Look at this. Not all data set. 80% of the randomly selected 80% of the my trained data here. Yes, I can give it to the model, and I can see the labeled output. Model will come from here, and training data will come here, and it will produce one result here. Also, this one is a waiting model, because we will use this model also for testing. Yes, and then now I am sending the accuracy result of the training to the here, and then I should also send it to the output here. Also, when you go to output, also you should send these ones are now available. Yes, from here I will get the test result. From here I will get the training sample result. So first one is a first performance is a test data result, 96%. Second one is a training data result. Look at training data accuracy is a 99%, but test data result is a 96%. Yes, if you report wrongly, my accuracy of your model is a 99%. It is wrong, because it's a accuracy report for you by using training data. In the training data, what is happening? Algorithm used to see your training data, and after that you are going to use same data set to measure the accuracy. Yes, your training algorithm used to see and used to somehow memorize your data. It's wrong, but this accuracy is correct, 96%, because first of all, I have trained my model by using training data. After that, when I trained and I get that model, and then I introduce the trained model to the brand new test data, which which algorithm which never seen that data before, and then I give it to that trained model, and then trained model told me some predictions, and I compare it with my real test data output. After that, I calculated the accuracy. This is the correct accuracy of my correct estimated accuracy, because still it is estimated. We cannot know 100% it is like that. We are trying to using some sub sample of data set to estimate. We can just estimate. This is but good estimated. And then also you can do, this one is a test data accuracy, trained accuracy. Also we can see all full data accuracy. How can you see full data accuracy? We can go to design. If you look at here, from here there is a training data coming. Yes, training data coming. This is the size of the training data. From here, if you look at test data, 29 of them we have used for testing. Yes, but if you go out, you will see that here, all data set here. Look at all data set here. Yes, all full data is set here. This means I can use this place to see the full data set. I can use the same things. Copy. Paste. Model will come here. This model, from where it comes, this training data, this algorithm, decision tree algorithm will get the training data, and it will produce model, and it will output from here. From when the testing finish, also it will output outside. Model also available outside. I am getting that available trained model, and then we thought this one is a full data set. Why full data set? Because 147, all of them here together. I am getting this full data set to do as an input of my model, and it is producing prediction, and then I am calculating from this prediction, and also I know the real answer and performance this module will produce. Now, what will happen? This one, the result of the test accuracy, data set accuracy. This one is a training data accuracy. This one is a full data set accuracy. Yes. Also, if you want to display model, you can output it model. When you run, you'll see the model also. This is my model. Yes. This one is a testing accuracy. This one is a training accuracy. This one is a full data set accuracy. Let's compare them in the here. Here. So this one, when you look at it, it is a heart beating of the, you can see the heart beating of the model. It is perfect. Yes, because it is expected. Training accuracy always should be higher. If model is not something wrong, if everything is okay, if heart beating of your model is perfectly working, running, this means training accuracy of your model should be higher than others. And then testing data accuracy should be less than others. And then full data set accuracy should be in between. Look at it's a perfect, there is perfect model. This means it is showing the perfection of your model, because in the full data there is a training data set and test data set. During the training, your training algorithm used to see your data, you used to memorize your data. That's why accuracy always higher. Also in the full data set, there is some part, training part already seen during the training, and when you use the full data set to make prediction, it is making more accurate prediction than test data. But when you give the test data sets, which never seen before, training algorithm never seen it before, it is making less accurate result, but it is quite close to these accuracies. It should be like that always. If there is nothing wrong, if your model is perfectly configured and learned and trained, accuracy should be like that. Training accuracy should be highest. Full data accuracy in between the testing and training. Testing accuracy should be less. So second method. In the second method, let's open new process. Before going to new process, let's copy paste some of them. Apply, because we will use this one and this one. Copy. New process. Here there is again there training data should be here. Let's disable them and let's see if there's yes, training data already there. We don't need to configure again. And this time we will use X validation. Validation. X validation. X validation is a name of the k-fold validation in the RapidMiner. If you are using X validation, this means k-fold validation you are going to use. You are going to give training data here. Again, this is a nested, and you should give model output. Let's give them output, and then let's take this one. Cut is nested. You can enter inside, and in this side we will test result. Yes, in this place we will develop our model, training model. It will be in this example decision tree. Decision tree here. By using model output here, model will come from here. Performance will go from here. Test data will come from here. So in this one, what's happening? We are dividing our test data to do 10-fold, 10 data, 10 part. One part will be used testing, remaining 9 part will be used training. In the second round, this means this validation will repeat it 10 times. In the second time, remaining 9 part will be used for training, 1 part will be used testing. 10 times it will be, yes. Then you go to enter, we are training here and testing here. This process will be repeated 10 times. It will get the average value because we are doing 10 times this operation. In 10 times, it will produce accuracy and then it will get average and it will report it. Yes, accuracy of it 93.990. Yes, accuracy of, if you measure accuracy of your model, you can estimate, this is also estimate, you can tell according to the, if you want to report it in somewhere, for example, in one report in one scientific research or somewhere, or in your project, if you want to report accuracy of your data mining or machine learning model, you can tell according to the 10-fold validation, accuracy of this model is a 93.9. Also, you can report the standard deviation. It can be minus plus 7. Yes, it can be minus plus 7 to this one. It can be minus 7 less than this one, or minus 7 higher than this one, because you repeated this test 10 times. You can calculate now. Also, you can report standard deviation. Yes, you can report the standard deviation also, because you repeated this one 10 times. So by the same way, let's do one of them is only this one. For example, let's do this one. Let's enter inside and then write. If you want to see more detail, write the text. We can write the result into the text. And then to where you want to write, for example, to desktop, test Irish. Test Irish. And then to the desktop, I want to save result. Also, you can make it for training. Also, when you can go outside and you can make it for all dataset, same. And this is my decision tree model. These are my examples, and then this is a performance of the test. Yes. And if you want to see all of them, we write it on the test Irish. This one. Open. You can open it. This one. Notepad. And you can see the result. For example, the result of the first one is a 100% accuracy. In the first subfold, accuracy 100%. In the second one, 100%. In the third one, accuracy is 86%. Like that, you have 10 result sets, and you need to get average of them to find the final test out. Yes, you can see all this one by one. So how can you do this one in the WEKA? In the WEKA also, if you remember in the previous lesson, we have used all our data set for all data set for training, but it was wrong again. Now let's do correct training. CSV. WEKA can work with CSV file, not Excel file, you know. In the previous lesson, we explained. And classification, for example, we want to use decision tree. We told in the WEKA decision tree algorithm called J47. J47 means decision tree. And then if you want to hold out test, you can do like that, 80%. For example, 80% of your data will be used training, remaining 20% will be used as a testing. And also you can tell here results and CSV. Okay. And start. This is the result of the 20% of the test result. Yes, 20% test result. Our decision tree looks like that one. They are the result. For example, first one, in the first accuracy, in the test data, first one, it was testing. It was verse color, and prediction also verse color. Actual one, it was verse color, predicted also verse color. And then 29 of them, because we told only 20% of data set use randomly, choose 20% and use it for testing. Yes. If you want to make 10-fold cross-validation, you should use this option. Yes, 10-fold. This means divide your data into the 10 parts and repeat this testing process 10 times and average all reports, sum of them, sum the all reports, test reports, and then divide it by 10 average, and then report it. Yes, when you start, according to the 10-fold cross-validation, accuracy of our model 95%. According to the holdout 80-20, 20-93. Yes, if you want to report somewhere, you can tell according to the 10-fold cross-validation, accuracy of our decision tree models is a 95%. Or you can tell according to the 80-20% holdout method, validation method, accuracy of our model, it is estimated, of course, estimated accuracy of our model is a 93%. You can tell like that. Also, we told validation data set in some algorithm using validation data set. Yes. For example, if we will choose instead of decision tree, multi-layer perceptron is one type of the neural network model. And then, first of all, let's use 10-fold cross-validation. According to the 10-fold cross-validation, accuracy of our model is 96.5, better than this one. Yes, 96, according to 10-fold. Or according to the, for example, holdout method validation, 80% of the data will be used for training, 20% of use will be used. Again, Irish flower dataset is not big dataset. That's why I am not using 70%. 80% I am using for training, and I am going to give more chance to make better training of my model. Yes, 80%, and then 20% of data will be used for testing and reported here. Start this one. Also, you can do one more thing, but because it is a neural network model, and you can go to here, its settings, and you can tell, I want to use 10% for validation. 10% for validation. And then if you fail 20 times, stop the training. Okay. What will happen now? 80% I have at the beginning, 80% divided for training, 20% divided by testing. And also 80% of the training data further divided into the 90% training, 10% for validation. Explicitly, I defined validation data set. This validation data set will be used to stop my artificial neural network in the right training point, and it will improve the accuracy. Yes, I can get maybe better result. You get 96.5. Again, same. You get same result. Yes. You can use one of these methodology. For example, you can if you can choose 80-20 and then 10-fold. 80 at the beginning, 80-20. After that, further 90-10, and then 20 for validation. All of them, it will work. This is a small data set, but if you are working with big data sets, sometimes to using validation data set, it may give better results. Also, you can use validation data set. We told, but if you want to use validation data set, explicitly you should define it. So you can do all of them also in the Python. Let's do this one in the Python. All this validation can be done in the Python also. This lesson became a little bit much, but who's patiently staying in the lesson, I'll give them extra some points. Create a new model, and we will do Python model. Python application. Next, Python application. Irish decision tree modeling. Let's start. So we know if you are developing one machine learning or data mining models, first of all, you should import your data. Yes, and you can make some discovery. In the previous lesson, we have explained these steps. I don't want to repeat this step again here. Just copy paste and run this code. And then you need to train your model, and you get the accuracy. So let's run these codes now. Control. If you want to run this code line by line, you can press Control Enter. Control Enter. Here, what is happening now? I am telling I want to use decision tree algorithm to train. Here, I am training using full data set. Inside the train and label, there is a full data set. And then I want to, here I am calculating accuracy of our model. But accuracy of our model is 100%. Yes. This means we can tell implementation of the decision tree is better than WEKA and RapidMiner. We didn't get this accuracy full data set. Yes. But this accuracy cannot be reported because it is using full data set. Yes, we should use training and testing. We should divide our data set. Yes, in train and label, we have full data set. We should divide it into the two parts. Yes, how can you divide it in the Python? Like that. If you are using hold out method, you should use this code. I will explain this code now. After till this part we have done in the previous lesson. That's why I'm not explaining, but I'll explain this part of the code. In the hold out, what I need to do functionality. I should import metrics and model selection. I will use train test split. Yes, this means inside the train I have full train input. Input, yes, data set input, and then inside the level I have targets. Yes, I have target them, and then I want to divide them into the 20%. This means test 80% of the full data set will be used for training, 20% of it for testing, and then randomly select 80% of it into the displays for train. 80% of data will go to this variable. 20% of my data will go to this variable. And then look at when I training here fitting in the Python scikit-learn machine learning library. It is a fitting. I am using training data. Now let's run them. Now, and we train our model by using training data section on it. And then to calculate the accuracy, I am using the test site. Yes, test site. That's why I'm going to give input coming from test data, and I am getting the prediction of my decision tree 2 model. Yes, this is second decision tree model I had generated from here. And then after that, I know the correct answers. And then I'm going to do predictive answer to do this function. This function will report the accuracy of the training data, test data. Yes, again, accuracy of the test data, again 1. Yes, this is the indication of the Python scikit-learn library using better implementation of the decision tree model. Yes, better implementation of the decision model. In testing data set also we get 100 accuracy. This means it didn't do any mistake. Let's do k-fold prediction. If you want to make the k-fold prediction, if you want to report accuracy of your model by using k-fold cross-validation, what can you do? In this time, you should import this functionality. They are implemented in here. And then I am dividing my data into the 10-fold. This function, k-fold, divided data set into the 10-fold. Yes, and then these training and test data will be saved inside the displays. And then this time I am defining new decision tree. Its name is a DT tree. After that, cross-validation score function. Now I am going to give as an input my data, input my decision tree, my full data set, and then my faults, and I want to get the report as the accuracy. And then from the NumPy library, I want to use mean and standard deviation function. I am importing them. And then inside the scores, there is a 10 scores. That's why I want to get their means and then standard deviation. Yes, 95%, 0.95. According to 10-fold validation, accuracy of my model, 95. And standard deviation is a 0.05 plus minus this one. This means it is a quite reliable. It is indication of the, if this number is too small, this means my model is a quite reliable model because it is not deviating too much. Yes, there is no fluctuation in the result. It is telling 95% correct. This is a more reliable accuracy than holdout. Yes, because why it is more reliable? Because to test the accuracy, it makes 10 times simulation of experiment. Yes, after that, it is reporting this one. This is a more reliable accuracy. In Python, scikit-learn, we have one more thing we explained before, stratified k-fold. Stratified k-fold. Yes, what is stratified k-fold? We explained it in the previous slide. Let's apply this stratified k-fold validation. It has specific implementation in the scikit-learn. These are not regular k-fold, stratified. This means if there is samples, when they are selecting randomly, it will keep the distribution or percentage of the labels. If, for example, if 90% of data coming from the class 1, when you are selecting data, 90% of the in each folder, 90% of data will come from the class A. If class B has a 10%, and 10% of the data will come from the B class. It will stratified fold. In this means in every fold there will be representative from the both class. If there's more class, for each class there will be representative. And again, when you run it, it will give you accuracy. This is a stratified accuracy. It is a more reliable, more trustworthy accuracy. You can do this one, I think, here in the study. If you open our process, you don't want to let this one. Hold out. Here, stratified linear sampling. What is linear sampling? When you are dividing data, keep the order. For example, if you have 100 in your data set, if you have 100 samples, if you want to divide it 80%, first 80 sample will be used for training. Last 20 sample will be used for testing. It is a important this type of the linear sampling for time series forecasting. Time series forecasting, it is meaningful. Yes, shuffle it randomly. Stratified is that one. Stratified is in the RapidMiner. If you want to make stratified sampling, you should choose this option. In the if you want to make stratified k-fold prediction, you should use this technique. So there's some reference. Let's go to beginning. If there is some missing things, let's see. we have seen this one, we have demonstrated this one. If you are working with neural network, you can explicitly further, you can divide your training data into the also training and validation test set. We have mentioned about this one. We thought we will mention them later. Use the defined parameter, system parameter. In the next lessons, we'll mention about them much, but let's see some example about it. What are they? For example, when you go to your model, decision tree, for example. Look at this decision. This one is a user configurable parameter. For example, we divided the model specification, how we are defining or developing your model according to its specification. Yes. For example, in this model, there is a hyperparameter. This hyperparameter means user-defined parameters. This means user can define this value of these parameters. For example, splitting criteria, how decision tree will be split, left side or right side, or which attribute will be choose a starting node. Yes. Which criteria, gain ratio, information, you can choose this one. Yes, you can choose this one. Also, maximum depth of your model. For example, if you go to result, for example, here, what is depth of 1, 2, 3, 4, 5, 6? It is, when you go to design, you told till 20 depth you can make, you can generate your decision tree, but our model is not complete, data set is not huge amount. That's why till 6, it is develop the optimum decision tree. But you can tell, for example, 3. It is user configurable. You can change this configuration. For example, you can make 3. And if you train by 3, look at now length of the decision tree will be 1, 2, 3, maximum 3. Actually, it can produce more complex and better tree, but you set limit. Make the decision tree model by 3 depth. And performance accuracy, look at, fell down. This model, it is not, is a, of course, training accuracy high. This is all data. This one is a testing accuracy low. This is not good. Yes, look at now, I am doing validation. This means I have validated this maximum depth. I find out it is not good because there's a better option. For example, if I will do 6 and I start it again, I will get more accurate result. Look at more accurate result. Now I have validated that maximum depth should be 6. How I validated it? By using test data. Yes, I am doing validation. Yes, by using validation data. Now I have used this test data for validation of the hyperparameter of the decision tree depth. Yes, this is a user configurable. How I will find the optimum best configuration value of this one to make several try and fail tests. Yes, by using validation test. Now I am using test data set as a validation. Yes. I am using test data. I am getting some accuracy that, and I am using it to validate this hyperparameter. Also, leaf size, for example, minimum leaf size. For example, we will see them later. Okay, they are just example. Let's see some example for the system parameter or model parameter or learnable parameter. This is model parameter shortly. Model parameter, system parameter means they are the learnable parameter. We are not configuring them. We are not trying to find out their correct values. Who's trying to find them? Training algorithm discovering their optimum values. Learnable, because it is a job of the training algorithm to find their optimum values. But hyperparameter is a job as the machine learning engineer job to find their optimum parameters. Also, but there is also some techniques to make them automatic also. You can use some optimization techniques to find their optimum values for hyperparameters also. But they are also 100% job of the training algorithm to find the optimal values. For example, what is the best splitting node? For example, when you go to result, when you want to see decision tree, you look at who decided pedal length should be starting this one. Learning algorithm decided, and then how it decided. For example, if it is pedal length bigger than 2.4, go to the left side. If equal or less than 2.5, go to the right side. Who decided these values? Learning algorithm decided. I didn't choose them. I didn't decided these values. They are the system parameter, learnable parameter. That values learned by the training algorithm. Yes, decision tree algorithm. Yes, they are learned by the tree. But who decided the length of this decision tree? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Maximum 5. Yes, and then to using much, it is not useless. For example, even if you tell much, it is not using. Yes, you can tell it is should be 5. How I am deciding this one? For example, if you choose at the beginning this one 3, it is, you should check the validation result 83, and then you should come here and then you should tell 4, and I should run it again, and then it is better than this one. Yes, and then it is improving. This means you can use 5, and then better than this one. Yes, decision tree 1, 2, 3, 4, 5. It is no more improvement. Yes, you can stop here. You don't need to go to further to try 6. Yes, you will try them like that. So I hope you understand the difference between hyperparameters and then system parameters. Is there anything we thought we will mention about later? So we mentioned everything. See you in the next lesson in that case.